This video I'm going to be talking about a few geometry problems from the AMC12. I'm going to talk about 5 problems and they're going to range from relatively easy problems to pretty difficult problems. So this problem is the 8th problem from the 2018 AMC12A. This problem reads, all the triangles in the diagram below are similar to isosceles triangle ABC in which AB equals AC. Each of the 7 smallest triangles has area 1 and ABC has area 40. What is the area of trapezoid DBCE? With a lot of problems on the AMC12, especially the earlier problems, most people will know the concepts and formulas necessary, but what's more difficult is to assess when to use what formula and when to implement what concept. So in this problem, we're told that all the triangles in the diagram are similar to isosceles triangle ABC. So we know that we're going to be using similar triangles to solve this problem. Instead of directly trying to find the area of trapezoid DBCE, it's better to try to find the area of ADE first and subtracting it from 40. This is because ADE is a triangle that's similar to ABC and all the other triangles in the diagram, and so it'll be a lot easier to find its area compared to finding the area of DBCE. Looking at triangle ADE, we notice that it contains this triangle right here, which we can call AMN. Since MN is 3/4 the length of DE, we know that since AMN and ADE are similar, that AMN has 3/4 squared times the area of ADE, which is 9/16. We also know that AMN has exactly 7 less area than ADE, so at this point we can make an equation with one variable, which we can solve. If we call the area of AMN x, we know that ADE is equal to x plus 7, as well as 16 over 9x. And if we solve this, we find that 7 over 9x is equal to 7, and that x is 9. So if x, or the area of AMN, is 9, then we know that ADE has area 9 plus 7, which is 16. Since ABC has area 40, the area of trapezoid DBCE is going to be equal to 40 minus 16, which is 24. So the answer is E. This problem is number 14 from the 2010 AMC12A. It reads, non-degenerate triangle ABC has integer side lengths, BD is an angle bisector, AD is 3, and CD is 8. What is the smallest possible value of the perimeter? So the first thing we have to do is to draw triangle ABC. We'll call this the angle bisector BD. And we know that AD is 3 and DC is 8. So by the angle bisector theorem, we know that AD over AB is equal to CD over CB. So because of this, we can call AB 3x and BC 8x. Since 3 over 3x is 1 over x, and 8 over 8x is also 1 over x. So at this point, the perimeter is 11x plus 11. And basically, we can just set it equal to each of these to see which one works. And by works, I mean we get an integer value of 3x and an integer value of 8x. If we plug this into 30, we have 11x is equal to 19, which doesn't work because we get x equals 19 over 11. 19 over 11 times 3 is not an integer. If 11x plus 11 is 33, this works because x is 2 here, and 2 times 3 is 6, 2 times 8 is 16. Just to be sure, we can check this with the triangle inequality. And we have 6, we have 16 here, and we have 11 here. And this does satisfy the triangle inequality because 11 plus 6 is 17, which is more than 16. So our answer is B. So this problem is problem 19 from the 2015 AMC12B. It reads, in triangle ABC, angle C is 90 degrees and AB is 12. Squares ABXY and ACWZ are constructed outside of the triangle. The points x, y, z, and w lie in a circle. What is the perimeter of the triangle? So in this diagram, we're going to draw ABC, where AB is 12, and C is a right angle. You know that ABXY is a square, and so is ACWZ. We're given that X, Y, Z, and W lie on a circle. We're going to pretend that's a circle. There's a theorem that states that if you take the perpendicular bisector of two chords on a circle, they'll always meet at the center of the circle. So in this case, if I take the perpendicular bisector of XY and ZW, they'll intersect at the midpoint of AB, which is the center of the circle, and we'll call this point O. Since we know where the center of the circle is, we can figure out the radius of the circle. We know that AO is going to be 6 and AY is 12 since ABXY is a square. Now we can find the length of OY, the radius, using the Pythagorean theorem. Now the OY squared is going to be equal to 12 squared plus 6 squared, which is 180. So we know that OY is going to be the square root of 180. So at this point, what we want to do is to set variables for the lengths that we're trying to find. So let's say AC is x and BC is y. So one equation we can make is x squared plus y squared is 12 squared, which is 144. The second equation we can make is less obvious, and it comes from this triangle right here. So this triangle right here has side lengths x plus y over 2, x over 2, and the square root of 180. And by using the Pythagorean theorem, we find that x plus y over 2 squared plus y over 2 squared equals square root of 180 squared, which is just 180. Wait, no, this is actually going to be x over 2. And if we simplify this, we get x squared plus y squared over 4 plus xy plus x squared over 4 is 180. We can combine the x squared over 4 and the y squared over 4 since we know what x squared plus y squared is. So we have x squared plus xy plus x squared plus y squared over 4, which is going to be 144 over 4. That comes out to, I think, 36 equals 180. So then we just subtract 36 on both sides and get x squared plus xy equals 144. And conveniently, that's also what x squared plus y squared equals. If we cancel the x squared, we're left with xy equals y squared. If we divide by y on both sides, we have x equals y. So basically what that means is this is a 45, 45, 90 triangle, and x and y are going to both be 12 over the square root of 2. Since in a 45, 45, 90 triangle, we have 1, 1 square root of 2 as the proportions for the length of the sides of the triangle. So 12 over the square root of 2 is going to be equal to 12 root 2 over 2, which is 6 root 2. So x and y are both going to be equal to 6 root 2, and the perimeter is going to be 6 root 2 plus 6 root 2 plus 12, which is 12 plus 12 root 2, and that's C. So this next problem is problem 16 from the 2013 AMC12B. It reads, let ABCDE be an equiangular convex pentagon of perimeter 1. The pairwise intersections of the lines that extend the sides of the pentagon determine a 5-pointed star polygon. Let S be the perimeter of the star. What is the difference between the maximum and the minimum values of S? So the first thing we want to do is to find the angle measures inside of the pentagon. So we know that the sum of the internal angles in a convex polygon is 180 times n minus 2, where n is the number of sides in the pentagon, or the polygon in general. Uh, with pentagons, we have 5 sides, so you plug in 5 for n and get 180 times 5 minus 2, which is 3. This is 540 degrees. Since you have 5 angles in a convex pentagon, and all the angles are going to be equal, we just take 540 degrees over 5 to get 108 degrees. Next, we can draw the diagram. The convex polygon ABCDE is going to look something like that. And each of the angles is going to be 108 degrees. If we extend the sides and make the star, then we're going to find that we have these triangles extending out of the pentagon, and basically we can come to the realization that since this side is straight, we have 72 degrees here, 72 degrees here, and therefore these two sides are going to be equal, and this triangle is isosceles. And this is symmetric for all 5 triangles. All these triangles are going to be isosceles triangles with 72 degrees as the base angles here. So let's call the sides of the pentagon A, B, C, D, and E. And basically what we're going to try to do here is find the relationship between the sides of the pentagon and the two equal sides of the isosceles triangles. So let's say this triangle, for example, has sides N, and E. So using the law of cosines, we know that n squared equals n squared plus e squared minus 2en cosine 72 degrees. These two n squares cancel, and we have e squared equals 2en cosine 72 degrees. This e cancels with one of the e's here, and if we divide by 2 cosine 72 degrees on both sides, we have e over 2 cos 72 degrees equals n. Since we have 2n on the perimeter here, we can multiply by 2 on both sides. So we have 2n here, and this 2 cancels on the left side here. So basically we have 2n equals e over cosine 72 degrees. So this is symmetric throughout the all the triangles. So basically here we have these two sides adding up to a over cosine 72 degrees. Here we have them adding up to b over cosine 72 degrees, c over cosine 72 degrees, etc. Right? So basically the perimeter S is going to be equal to a over cosine 72 plus b over cosine 72 plus c over cosine 72 up to e over cosine 72 degrees. So basically this is what we have as S. Since a plus b plus c plus d plus e is just the perimeter of the initial pentagon, which has perimeter 1, this entire value is just 1. So basically we know that S is equal to 1 over cosine 72 degrees, which is also secant 72 degrees. And this means that there's no variation between the maximum and minimum value of S, because no matter what you put as A and what you put as B and what you put as C up to E, they're always going to add up to 1. So your answer is A. So this is a question from the 2010 AMC12B. It's question number 22, which means that it is relatively difficult. It reads, let ABCD be a cyclic quadrilateral. The side lengths of ABCD are distinct integers less than 15 such that BC times CD equals AB times DA. What is the largest possible value of BD? So for this problem, we have to first draw a diagram. A cyclic quadrilateral means that it's inscribed in a circle and has a lot of different properties. Uh, for example, the opposite angles in a cyclic quadrilateral will always add up to 180, right? And that's going to be used in this problem. So let's say we have the circle, and we have ABCD inscribed in it. This is probably not accurate in terms of proportion, but that's okay. To maximize the value of BD, we also have to find the maximum value of BC, CD, AB, and DA. However, they all have to be less than 15, so we can just try out some values. For example, whoa. For example, BC, let's say BC is 14, since that's the largest integer that's less than 15. So if BC is 14, we have 14 times CD equals AB times DA. Having a 14 on the left side means that we have to have a factor of a 7 and a factor of 2 on the right side. And since they all have to be distinct integers, I know that one of these factors has a 7 and one of these factors has a 2. So we can just like assign them to either. It doesn't really matter. So let's just say AB equals 7. Because AB can't be a bigger multiple of 7 than 7, just because if 7 times 2 is 14, that's already taken. 7 times 3 is 21, that's already more than 15. So we know that AB is 7, and DA is 2 times some number, right? Some constant. The biggest multiple of 2 that's not 14 and less than 15 is going to be 12. So K is equal to 6. So we know that DA is 12, AB is 7, BC is 14, and CD, just by simple algebra, is going to be 6. So we can just write these down. So now we can start solving for BD. By the law of cosines, we know that BD squared is equal to 14 squared plus 6 squared minus 2 times 14 times 6 cosine C. We also know that BD squared is equal to 7 squared plus 12 squared minus 2 times 7 times 12 cosine A, which is actually 180 minus C, since it's a cyclic quadrilateral. Now, cosine of 180 minus C is just going to be negative cosine. So we can just change that and say this is actually going to be plus 2 times 7 times 12 cosine C. So now what we can do is we can add these together, since 14 times 6 is equal to 7 times 12, which they're both 84. So these two parts will cancel if we add the two equations together. So we can say 2BD squared equals 14 squared, 196, 6 squared, 36, plus 7 squared, 49, plus 12 squared, 144. So just adding these together, this is 180. This is, I think, 245. And this is going to come out to be 425. Dividing that by 2, we have 425 over 2 equals BD squared. And so we have BD equals 425, the square root of 425 over 2. And that is D. Thanks for watching. If you enjoyed, please leave a like and subscribe. If you have any questions, you can leave it in the comment sections, and I'll try to reply to you as soon as possible. And I'll be posting a new video every Friday, so turn on notifications if you want to be notified when that comes out. And thanks for watching, and I'll see you guys next time.